The universe is packed with worlds, and the more we discover, the clearer one thing becomes. Earth isn't normal, Earth is lucky. Most planets out there are brutal. Some are baked by their stars, some are frozen solid. Some have air that would kill you instantly. But then you find a different kind of world, one that might have weather, clouds, rain, storms, and maybe water. Water isn't just a pretty detail. It means chemistry can run. It means cycles can exist. It means a planet might have a real shot at being alive. But water can also be a trap. A planet can be covered in ocean with no land at all, and that changes everything. No ground, no mining, no easy building, just a floating outpost fighting storms, corrosion, and the clock. Today, I'm testing one of the most famous ocean world candidates, Kepler 22b. What helps us, what kills us, and what we'd have to build first to survive on a planet where the ground never shows up. My name is Neil. I run a series where I test worlds for long-term human living, not as fantasy, but as engineering. Every episode, I break down 4 things: the environment, the main risks, realistic solutions, and a final verdict. Today, Kepler 22b, and one terrifying scenario, an endless ocean. Let's be honest about the data. Kepler 22b is real. We've detected it. We know its orbit, we know its size. It's bigger than Earth, about 2 Earth radii, and it circles its star in roughly 290 days. It sits in a region that gets a similar amount of starlight to Earth, but here's the key detail. We don't know what it really is. It could be a rocky super-Earth. It could be a mini Neptune with a thick atmosphere. Or it could be a water-rich world, an ocean planet. So today isn't Kepler 22b facts. Today is an engineering question. If this is an ocean world, can we live there? An ocean planet sounds peaceful, but for colonization, it's one of the harshest setups you can imagine. Because land is more than a place to stand. Land is raw materials, stable foundations, mining, construction, repair, expansion. An ocean world takes most of that away. So if Kepler 22b is covered in water, it becomes a test of something bigger. Can humans build a civilization on a planet where the ground never shows up? The first danger is the air. A planet this size can hold a serious atmosphere. Maybe dense, maybe hot, maybe chemically hostile. So even on an Earth-looking ocean planet, you should assume you still need sealed habitats, pressure control, air recycling, oxygen production. Because there's air doesn't mean you can breathe. Now the big one. If there's no land, everything becomes logistics. Where do you get metals? Where do you get replacement parts? Where do you build large structures? On Mars, at least you have regolith and rock right under your boots. Here, you have kilometers of water first. So your first colony isn't a city. It's a floating industrial outpost that survives by strict inventory, constant maintenance, and careful expansion. An ocean world turns your colony into a machine that can't stop running. Oceans don't just sit there. Water plus atmosphere equals energy. Energy becomes wind. Wind becomes waves. And waves become structural fatigue. Picture this, a fragile floating platform, and a storm system that doesn't pass by. It lives on the planet. Waves that slam into your base for hours. Wind that tries to tear your modules apart. Salt corrosion, moisture, constant stress. On an ocean world, your enemy isn't one disaster, it's the planet's normal mood. This is the most ironic part. You can be surrounded by water and still die from lack of air. Oxygen isn't a gift here, it's a product. You need power to split water, power to run filters, power to store oxygen safely, power to keep the habitat pressurized. So on this planet, power isn't nice to have. Power is breathing. Now the quiet killer. On land, you can walk somewhere. On an ocean world, you're trapped on a platform. No real sense of place. No landmarks, no ground, just water and depth. Even if the base works, the human brain may not. So the colony must be designed like a long-term mission habitat. Private space, routine, light, plants, mental health protocols. Because without that, you don't fail mechanically, you fail psychologically. So what would actually make sense? A Kepler 22b ocean colony starts as a floating habitat hub, heavy storm-resistant structure, sealed modules with redundancy, strict maintenance infrastructure. Then it scales through systems, not land, closed-loop life support, water processing, oxygen production, and serious energy generation. You also need mobility. If the atmosphere is dense, aircraft and drones become your roads. If storms are constant, you need autonomous systems that can work when humans can't go outside. This isn't a beach colony, it's a floating industrial system that survives by routine. My verdict on Kepler 22b as an ocean world? Can humans survive there? Yes, if you bring sealed systems and reliable power. Can we build a colony? Theoretically, yes, but only as a storm-proof, maintenance-heavy floating outpost. No land means no easy growth. Everything is chemistry, logistics, and energy. Kepler 22b's value wouldn't be comfort, it would be the ultimate test. Can humans build a stable life on a planet where the ground never arrives? Survival today? 3 out of 10. Colony potential? 6 out of 10. Engineering difficulty? 9 out of 10. Best format? Floating habitat hub plus strong power plus closed-loop life support plus drones. Next world test? A lava world. Or a fake Earth that looks friendly until you learn the truth. Comment lava or fake Earth below. And subscribe, because the next planet won't test your courage, it'll test your systems.